All right, so we are going to do a conical tank. A conical tank is just a cone. So let's draw a picture of a cone. And it's vertex down. It is 10 feet across the top. If it's 10 feet across the top, what would that make its radius? 5. And it's a total of 12, excuse me, 12 feet each. Okay.
Are you recording?
I am. So, what we have going on is, in this case, we have water flowing into the tank, okay? So if you can imagine the water going into the tank. And so here, at the bottom, okay, there's all kinds of things, ways that the shape is changing. First of all, if I have a constant rate, the way that the volume is going in is constant, okay? Right? If I have I'm pouring at a constant rate, the way that the volume changing is constant. But because this is a cone, at the bottom of the cone, do you see how the radius and the height at first are going to increase pretty quickly? But then because it gets wider, it's going to change. So what we're given is the water is flowing into the tank at a rate of 10 cubic feet per minute. So what I'm going to write for that is dV, which write dV over dt is 10 feet cubed per minute. All right, now, just so you're clear, on the homework double check, one of the problems I think might be it's dripping out of the cone. So how do you think you'd change the rate then? If the water's coming out of the cone, or it might be coffee. You just make it negative. So if I'm putting something in, it's filling up, the volume's getting bigger, it's positive, and then if I'm taking something out, it's negative. All right, so what does dV dt mean? That just means that's how is the volume changing. The volume changing is 10 feet cubed per minute. Okay, now, here is one thing that's true. As this cone is filling up, even though the radius and height are different values, they are still in the same ratio, okay? It's kind of like a little triangle. As I go up, that triangle is going to be similar every time, so the ratios are going to be the same. So what is the ratio of the radius to the height? Just write that down. What's the ratio of the radius to the height of the cone? 5 to 12. All right, now, that doesn't mean that everywhere in the cone the radius is going to be 5 and the height is going to be 12, but it does mean that it's going to be in that same ratio and proportion as the water moves up. So I can write that down. All right. So we are given this. The question is this. Find the rate of change of the depth of the water when the water is 8 feet deep. Okay. Now, so I'm going to take you away from that to just remind you what the volume of the cone is. It's 1/3 pi r squared times height. Okay, so I have 3 different variables here. I have v. What else do I have? R, and I have h. And in a minute when I derive, then what I have is dV dt. That would be how the volume is changing. How the radius be? How would I write that? How the radius is changing. dr dt and dh dt. I want you to read this sentence to me. Not to me, in your head a minute. This last sentence. And I want you to pick which one of those things I'm finding.
I'm sorry, he doesn't know. Usually everything that he thinks also translates to what he says.
Usually?
Yeah.
Okay. We'll leave it at that. All right. Do you guys see how the depth of the water is the height of the cone? So if I want to try to find the rate of change, I'm trying to find dH dt. I'm going to put a question mark. So all that means is eventually I'm going to have to take the derivative and I'm going to be solving for this. Okay. Now, this is where, if you can, you want to rewrite, because R doesn't matter. I don't want to find dr dt. I don't care about it. Nothing about it is mentioned in the problem. So here's what I'm going to do. How can you use this formula right here, because the ratio is going to be the same. Can you rewrite this for h? Cross multiply. 5h equals what? 12r. Solve for h. I'm sorry, solve r for h. That doesn't make sense.
You want h by itself or r by itself?
I want to rewrite r in terms of h because I want all h's in my formula. Because I want to find dH dt, I don't care. I want r gone. So I'm going to get r in terms of h. So I'm going to write 5h over 12 so that when I'm rewriting this problem, now r will be gone. Okay, here's what this avoids. This avoids, when we take the derivative, having to do messy things like product rule and implicit differentiation. We want to avoid that if we can. Okay? Like, some textbooks will have you leave the r in there. They'll have you go back and figure out the radius when the height is in, then you use implicit differentiation, blah, 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 blah. It might be a little extra step at the beginning, but now r is going to be gone because I don't need it in the problem. All right, so can you guys tell me then, let's rewrite our volume formula. It's 1/3 pi r squared. What are we going to write? 1/3 pi 5/12h. Can you put a parentheses and square it? Because it's the whole radius, right? Times what? H. All right, now, this is where we have to think really hard and do some mental math. So, what's 5/12 squared? 25 over 144, and then could I write it as h cubed because it's h squared times h? Are we all good with that? Okay. Try to avoid using your calculator. Noah. Okay. Can we do 3 times 144? Sure we can. Okay, listen. Do I understand that, just in case this is something that you might see on a calculator, non-calculator, 4 times 3 is 12, carry the 1, right? 4 times 3 is 12, plus 1 is 13, 432. Okay, so here's what we got. I just did 3 times 144, so I can write this as 25 over 432 pi h cubed. Okay. Remember, again, what's our goal? What are we trying to find? Why? Because we want to find dH dt, and we can't find dH dt unless we take the derivative. Okay, so let's take the derivative with respect to time of both sides. How would I write that? dv dt over here, which, ding, 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 we're going to be able to put in a second. Over here, we're going to use the power rule, so I bring the 3 down to the front. That would be 3 times 25 over 432 pi h squared. But remember how in implicit differentiation, when we did a different variable, we have to write dy dx. Here it's h, so we write dH dt. Because we're deriving with respect to time. That's why over here I wrote dv dt, and here when I derive with respect to h, afterwards I write dH dt.
There's no t on the right side.
So these are all with respect to time. Okay. All right. Now the rest is solving, guys. Can you put in anything from the problem into this equation? We knew dv dt. What is it? 10. So I'm going to put 10 in right here. Okay. Now, I can do one of two things here. I'm going to try to, if I can, simplify as I go. Do you remember how we knew 3 went into 432 up here? Wasn't 3 times 144 432? Can't we just do this then? Are you all okay with that? Okay.
Yeah.
All right, I'm going to just reduce it while I'm at it. So I have now 25 over 144 pi. Now notice, I was trying to find the rate of change of the water when the water is 8 feet deep. So what's H? 8. And what am I trying to solve for? dH dt. Alrighty. Let's try to do this without our calculator if we can. Why not? It's good practice. On this side, let's simplify as much as we can, okay? So 8 squared is 64, correct? And that will go on top of the fraction. So I have 64 times 25 over 144 pi. Are you following that? I just simplified that expression. Okay. Hey, I understand other people have different ways of canceling and simplifying, so that's the way I'm doing it. I'm just going to write it out and try to cancel some things. Alright, so here's what I'm going to do. I'm going to get dH dt alone, and then I'm going to try to cancel out as many things as I can cancel. Okay? To get dH dt alone, wouldn't I multiply both sides by the reciprocal? Okay. What that leaves me with then is on this side 10 times the reciprocal of this. So this would be 144 over 64 times 25 pi equals dH dt. Okay, so really guys, I have solved the problem. All I'm doing right now is arithmetic. Because at this point you could have gotten your calculator out, right, and done it?
But you told us not to.
Well, I told you not to, so let's try. Can you guys see anything that goes into like the top and the bottom? Oh, let's do some 5s. Okay, does the 5 goes into 10? How many times? Twice, and here 5 times. Okay. So now I have 2 times 144 over 64 times 5 pi equals dH. I'm just simplifying here, guys. All right. What else can you do? Can we do 2 and 64? What? Do you want to do 4?
Well,
You can do whatever you want, honestly, because a lot of things go in. I might have to simplify several times.
You could take out your calculator.
I could, but I'm not. Okay, 1 and 32. Are you all okay with that? So now I have on top 144 over 32 times 5 pi equals dH dt. Should we take a 4 out of 32 and 144? Alright, let's take a 4 out.
So 36 over 8.
I think we can take something else out, can't we then?
Yeah.
You can take a 4 out again.
No, I don't see it.
Take a 4 out again. What's this?
2.
A 4. 36 divided by 4 is 9. What's 8 divided by 4?
That one's 2.
Yay, look at this. I think we did it. Alright, what do we have? 9 over 10 pi, and the pi is on the bottom, equals dH dt. Okay, now, I just want to point out to you, at what point did we stop the calculus? Right there. Okay, just saying. Just saying, yeah. So this is just a little practice in case, I don't want you to make mistakes on your AP exam when you have to like square fractions and all that business. Okay, here we go, guys. Now, what if I asked you to approximate this rate? Can you guys now get your calculator out? Tell me to 3 decimals. What does this